SeaTunnel-Part has recently been released and added some new features that are easier to use. Today I'm going to record a video to give you a brief explanation. The main purpose is show how to sync data from MySQL to Doris and MySQL CDC to Doris. These two examples will give you a brief explanation of the new features. There may be 2 episodes. MySQL CDC scenario will be in the next video, and Doris scenarios. First, we will deploy our environment according to the Quick Start document. We will deploy according to the deployment of the deployment page. First, we download our installation package. After downloading and unzipping, we will install our connector plugins through the install plugin.sh script. In SeaTunnel, all the synchronization needs to be done using our connector plugins under the plugin list of plugin config. There are the documents corresponds to the connectors that we need to download and install. After editing the document, we run the script and download the connector. In order to demonstrate default text, I downloaded connectors of MySQL CDC, GDC, and Doris. We need to start our service. We can see that the service has started. After starting, we need to check if the service is normal. We can run a test through the script. After the SeaTunnel installation is complete, a test script will be created under the config window. It will be convenient for us to verify if the environment is normal. In SeaTunnel, the SeaTunnel.sh is mainly used for the configuration of the service. Let's take a look at some of its parameters. Here, we can see that we can specify our config file. Let me test it. The cconfig v2 batch template is used to verify if the batch service is running normally. We can see that the service is running normally. End with state finished command line. There is also a v2 streaming configuration file to verify if the streaming service is running normally. The streaming service is running in the service, so we can see that it will not report any errors, and it will not end. I will directly cancel it. Here, let's take a look at if the streaming is still running. We can see that the v2 streaming configuration file has been canceled. Next, let's take a look at how to run a test. First, let's take a look at my test environment. I have a MySQL environment here. In MySQL environment, I will show how to sync 2 tables. From the QA source library, you can see one is the table MySQL to Doris. There are various types of data. The second table is this one. It has a lot of data types and components. We will choose some components from here to run. This is from MySQL. I have a Doris environment here. In this environment, there is a E2E sync. Our goal is to connect the 2 tables in MySQL. In MySQL to the E2E sync in Doris database. I have already run these 2 tables before, so the tables are already there. You can see that there is only one table. Now, once our goal is set, we will look at our user files. I suggest that when we use Doris or SeaTunnel, because it has a lot of connectors, and each connector has different parameters. When we are writing the configuration file of the connector, we should take things for granted, but we should follow our files and write accordingly. First, we will look at the source of MySQL GDC. You can see that in the source folder. there is a document of GDC. At the same time, in the MySQL database, there is also a document called MySQL. What is the difference? In fact, in the early days, all the databases were in the GDC folder. However, as the number of databases supported by the GDC connector increases, there are some parameters, such as this parameter, which is used for the ocean-based database. For the MySQL database, it does not need this parameter. As the number of such cases increases, we will separate some databases into separate folders. So sometimes, we may need to refer to the GDC folder and the corresponding database folder at the same time. Let's look at the MySQL folder. In this folder, we can first look at the version supported by it. What versions of MySQL and engines are supported? Spark, Flink, and Zeta are all supported. If we want to use different engines before the connector, what do we have to do? This is a dependency that we use. We must strictly follow the document, step by step. We can see that if we use Zeta engines, we need to download the GDC folder and put it under the SeaTunnel and Lab folder. We can open this link and have a look. This link is actually in here. Then we can choose a folder and paste its link. Then go to the SeaTunnel folder. For example, under my installation folder, I have already downloaded the version 8.0.21. Once downloaded, we can continue to look at it. We can see that GDC source connector supports the batch sync mode, not the streaming mode. Column projection is actually the list. To do synchronization, it supports parallel reading, user-defined partition, and multi-factor synchronization. These are some key features. We can see them here. Then we can see some of the ways it is used. The library is MySQL. Its driver is like this. Its URL address is like this. Then it is actually a field type mapping. It tells us the different types of MySQL. It maps out the types in SeaTunnel. You can see that in MySQL, there is an int1 and an int unsigned. There are also some types like this. Then below, we can see this kind of thing. It is called not supported yet. We currently do not support this type. You can see it through this, okay? Of course, this is actually useful for developers. For our users, they do not pay much attention to this. What users need to pay attention to is the source options. This is all the connector parameters that. Let's see. The first feature is the URL address of GDC. It gives us an example. Then its driver is like this. Then there is user. It's about the name of our library, password, and query. We can read data from MySQL. These are some timeout parameters. I will not go into too much detail here. Partition column. This is mainly used to make the configuration of the partition rules. I will talk about this later. Including this. These are all related. These are all used for partitioning. The next feature is the fetch size. We know that when we read data through GDC, it is actually after the data is checked by the server. The client can take part of the data to the client at a time, then prevent me from taking all the results at once. Otherwise, it will crack down the client. Then suppose I want to set some parameters. Then I want to set some parameters in the GDC connection. For example, I want to add some parameters such as question marks in the URL address. Then we can use the properties parameter to make a configuration. This is a map type parameter. We just need to specify cov. The table pass is mainly used to specify the name of the table that we want to synchronize. When the single table is synchronized, then it introduces what its format is for different databases. For MySQL, it is a format such as database plus table name. For Oracle, we need to specify a format such as schema plus table name. For SQL Server and PG, it is the same. It is a format such as database plus schema plus table. We need to choose according to the type of different databases. The table list parameter is a property. This parameter is a feature added in the 2.3 and 2.4 versions. It can support a multiple table synchronization. The table pass can only be used to pair a table. Then we can pair multiple tables through the table list. At this time, I can synchronize multiple tables in a single synchronization task. This parameter is actually used to specify a while condition. In this while condition, it says that we must start with the keyword while. This while condition is valid for all tables. For example, I paired a table list with 10 tables. When I paired the while condition, I specified id100. When it reads the data of these 10 tables, it will pair with a while id100. This is to be noted if we want to add while condition to a certain table. What should we do if we don't add other tables? We will talk about this later. Split size is mainly used to control how many slices the table needs to be divided. Sorry, not how many slices. This is about the size of each slice. I will talk about this later. This is also related to the slices, okay? There are some common parameters below. The common parameter is to pair with the result table name. It also pairs with the parallelity and the result table name. The result table name plays a role. When the source is paired with the result table name, then the transform or sync below is paired with the source table name paired with the source table name. If they are paired with the same table name, it means that they are a pipeline. The data of the two relative names will be transmitted to the next source table name, which is a similar processing node. The parallelity is how many parallel paths I need to use all my slices. Okay, now we'll introduce the slice reading. In GDC's source, we support the slice reading. The slice reading is based on our components, or the only source. At the same time, I need to check how many parallel paths the data has. Then I will do the slice reading. For example, I can specify a partition column here. If the partition column is null. If we don't have a partition column, and find the component or the only source from it. If there are multiple components in the component and then it will use the first component in the component and the only source, which is the one at the front, to do the slice reading. For example, my table has a component. It has an int of a GID type. And then lem, it's a VH type. Because this GID does not support this kind of partitioning. So lem does not support this kind of partitioning.